Hi, everyone. Welcome, and thank you for attending today's IBM Middleware User Community webcast. Our topic is how to be an integration ACE with App Connect Enterprise. All phone lines are in listen-only mode, and please note the audio is being played through your computer or device. Today's session is pre-recorded. However, we still have the presenter on the line to answer any Q&A throughout the webcast, specifically at the end. So if you have a question, please submit them via the Q&A widget on your screen. Tomorrow, we will have the recording and the slides available for download, so stay tuned for an email that you'll receive tomorrow with a link to download the replay and the slides from today. So with that, I'll go ahead and introduce our speaker. We have joining us Ben Thompson. He's an Integration Bus Chief Architect with IBM Hybrid Cloud. All right, so with that, we'll go ahead and begin today's session.
So, hi everyone, my name is Ben Thompson, and today we'll be talking about how to be an integration ace with App Connect Enterprise version 11. For my sins, I'm the chief architect for that product, so I'll be stepping you through some PowerPoint that introduces you to the product. I'll also be doing some examples. We'll be diving into the toolkit and also into our web UI for administration purposes, and be talking about all things ace for the next 45 minutes to an hour. So let's start with what IBM App Connect Enterprise is. Many of you perhaps will have heard of IBM Integration Bus, or IAB for short, which was some industry-trusted technology we've had for a lot of years now. It's had many different names over the years. It actually started life in the late 1990s, and since then has been known variously as Webster Message Broker, MQSI if you go back that far, and then more recently since 2013 as IBM Integration Bus. And most latterly, we've renamed it to IBM App Connect, specifically IBM App Connect Enterprise, because it's an enterprise piece of software for connecting applications. Now, what IBM App Connect Enterprise version 11 gives you is not only the runtime technology that's previously been branded as Integration Bus, but it also gives access to some what we call cloud-native technologies, so running on IBM's public cloud, available for you to invoke either from software or run directly up on the cloud there. So we're confident of giving you here software capability and also cloud capability for all of your enterprise needs, as we say here, across the modern digital enterprise. I'm going to focus mainly today on the software aspects of the product, but I am going to talk about the various different UIs that are available on our public cloud as well. So the purpose of this particular chart is to show that all in one place. If we start on the left-hand side of this chart, in the bottom left quadrant, we're showing what is known as the App Connect Enterprise Toolkit. This is our Eclipse-based IDE, which is used for creating all of the artifacts which are then used to perform integrations, so message flows, message models, XML schemas, snippets of Java, eSQL, .NET code, you name it, we've got all those capabilities as part of the box. And those are created within the toolkit. So this is a fat client. It requires you to have an Eclipse installation on your desktop, and that's provided to you as part of our single package installation with a software product. Moving to the top left quadrant on this chart, we can also see our web-based administration tool. So this is served up from the integration server part of the product and is still again installed as part of a software implementation. And this web UI looks significantly different to the Integration Bus version 10 web UI, which some of you may be familiar with seeing in the past. You'll notice that the look and feel here is that we have several square tiles, each of which represent things that have been deployed into an integration server. I'm showing you this web UI at the level of an integration server. We'll talk more about how servers are grouped together as part of an integration node architecture, and also how they can be run standalone. But one of the major advantages with version 11 of this software is we now have the ability inside a single web browser tab to view everything about your integrations across your integration estate, so not just a single integration node as was the case in version 10. If we look to the right-hand side of this chart, we can see another couple of interfaces. One is called our Designer. This is a software authoring tool. It's available as part of our managed service on IBM Cloud, so it's part of our public cloud, and it enables you to create flows. It's a little bit simpler than the method of creating flows inside the toolkit. In the wiring diagram that you can see here, there's just a single path from the left to the right. We can link together various different components, various different parts. So we have here some Salesforce nodes. We have a callable flow node that you can use to invoke one runtime from another. And we also have a set of actions and events. You can create flows for APIs with this tooling. And it's designed really to be a little bit more straightforward. You don't need to be an experienced integrator to use the Designer. In the top right corner, we've then also got an administration UI, which is served up again from the public cloud. So this is enabling you to view artifacts that have been deployed to IBM's managed cloud, and those artifacts include those that are created both inside the designer and also inside the toolkit. So you'll notice in the example on this particular chart in the top corner, we have flows that have been deployed as part of applications. They're running inside integration servers, and the flows at the base of that dashboard are showing you the flows that have been created inside designer. So no presentation like this would be complete without some form of roadmap chart, and we've got two for the price of one here. This is actually showing both Integration Bus version 10, which is currently still in market and will be until April 2021 at the very earliest, probably longer. And we've also got AppConnect Enterprise version 11 shown above the timeline here as well. We have a quarterly release cycle for AppConnect Enterprise, so we have one fixed pack released every quarter. The first one came out as version 11.000, and that was released to the market in March of 2018. We then had subsequent follow-up fixed packs every quarter of last year, the last of which came out just before Christmas 2018, and that was ACE version 11.003. You can coexist these different fixed packs alongside one another, so you can install them all onto the same LPAR, the same platform, and they can run alongside one another. Literally just start with one, stop with another, and off you go. Now, fixed packs are about maintenance for the product, but they're also about new features. So in all of the boxes that you can see on this chart, you'll notice a rich array of features that we've added to the code base. Below the line, you'll notice slightly less words added into the version 10 stream. So gradually, we're putting less new features into version 10 and making that stream of delivery much more about maintenance, and adding more new features into the newer version of the software in version 11 to try and encourage you folks to move to V11 as soon as you possibly can. Version 11 has had quite a few landmarks over the last 12 months. When we first brought ACE version 11 to market, we did so in order to really satisfy those who wanted to run the software natively within container-based architectures, specifically within Docker containers, and most frequently running within a Kubernetes orchestration framework. So for that matter, we had standalone integration servers provided for the first time as part of our 11 GA release, as part of our general availability. Since then, we've reintroduced the concept of an integration node, which is used to look after servers and typically wouldn't be used within a container. So that's really to cater for those users that want to maintain an architecture like they've used in the past, possibly stick with an enterprise service bus pattern if they want to continue using that, which you can absolutely do with the ACE version 11 software. The latest release, 11.003, also reintroduced a set of new features, including multi-instance HA. We've got a chart here that can show you those features. Every time we release a fixed pack, we blog about it. We have a new entry. The link is at the base of this chart that tells you what has been provided there. So most recently, we provided multi-instance high availability. This enables you to have a standby integration node running on one machine with an active node running on another, with a shared disk system between them, so that we can automatically take over in the event of a hardware failure on one of those systems. We also introduced full support for all forms of XA two-phase commit. So if you're looking to do global message flow coordination, make sure your database is updated at the same time as your messaging system, or vice versa, both committed together. We can achieve that using the XA protocol, and that's available across both ODBC endpoints, JDBC endpoints, JMS endpoints, and also KIX services as well. We also reintroduced the concept of user-defined message flow nodes, both those written in Java and in C. Those capabilities were there in IRB version 10 and were not yet added back into version 11 until Fixpack 3, which was, as I say, delivered just before Christmas time. Some other enhancements came along in Fixpack 3, so dynamic monitoring, the ability to switch on and off flow statistics and change those flow monitoring events using the commands that are listed on the chart here. And we also made the policy information, much more to talk about where policies are concerned later in the deck today, to make policy information available from Java outside a Java compute node. And we have updated language translations for our users who don't have English as their first language. So lots of handy new features and functions added as part of that Fixpack 3 release that came out in December. We're still continuing to provide fixed packs on version 10 as well, and you'll see the latest one of those also came out a very similar time frame just before Christmas, and that was 10.00.15, and that provided capability to support MQ version 9.1, the latest long-term service release for MQ, and also a point feature to enable you to define multiple LDAP servers that you might want to connect to. In the event that one fails, we'll automatically attempt to connect to another one that you've specified there. So let's talk about the actual architecture of AppConnect Enterprise. This diagram should be pretty familiar to integration bus users. What you'll notice here is we have the concept of the main runtime process called the integration server, and deployed into that process we have a set of artifacts, message flows, applications, libraries, both static libraries and shared libraries. These are all the kinds of artifacts that you might already have created in previous versions of the software, and you can bring those forward with you, so any investments that you've made in the technology previously, they're all nicely protected. You don't have to recreate all of those artifacts, they're already there and you can use them straight away. What's also shown on this diagram is the fact that you connect that integration server to carry out administration tasks across a REST API. It's an entirely new REST API with version 11. We've called that API v2 because API v1 was offered with version 10, so we hope that makes a little bit of logical sense. And we use that REST API in order to connect up both our administration web UI and the toolkit across that same REST interface. You can also create your own HTTP administration clients if you wanted to. You could send commands directly using curl or other HTTP clients of your own choosing in order to effect administrative changes to that server as well. Typically what users would do is use their toolkit to generate artifacts, check them in and out of version control, and then deploy them into an integration server. So all of those capabilities are still there today as they have been in previous versions of the product. What this chart is designed to do is to step through the major fundamental architectural changes that have come along as part of the move to version 11. I mentioned earlier that we've really gone back to basics in order to take the product and make sure it's very amenable for deployment into a container-based architecture. So in version 10, shown on the left of this chart, we had the concept of an integration node process looking after one or more servers. If any of those servers had a problem, they would automatically get restarted by that integration node. So if you hit the U limit, for example, for the amount of memory that should be available on the platform, if you hit that hard memory limit, then we would just restart that server process and it would pick up again from where it left off. Now, I'm showing on the diagram here the use of a node and its associated servers deployed into physical machines or virtual machines. You can deploy an integration node inside a Docker container, but this is slightly non-intuitive. If you're a Docker purist, you would say, well, it's the job of my orchestration framework to look after those containers. I shouldn't need to run a node process inside that container as well. And so despite the fact that we've supported running Integration Bus version 10 inside Docker containers since back in 2015, we have actually noted here that we need to change our architectural design where containers are concerned, and with version 11 introduced the concept of a standalone integration server. So that's what's shown in the top right corner of this chart, where the integration server process, the light blue rectangle that has the flows deployed into it, that's actually running inside a Docker container. Other changes to note here is that the broker archive files that carry your artifacts into that runtime, they're deployed again through the administration interface that we talked about earlier, the REST API, and carried inside that bar file you could have all of the kinds of artifacts you've had previously. So I'm just, for brevity's sake on this chart, showing a flow and a policy being carried there. Now, policy is a new kind of artifact. It's conceptually very similar to the idea of a configurable service from Integration Bus version 10. Policy gives information to the server about how to communicate with a third-party system. So it might be something like an LDAP server, or it might be an FTP server. Tell it the IP address, the port number, that kind of information for how it should communicate. Policies can also be used to give other configuration information to an integration server. So it might be used to define things like an activity log, for example, where to log data onto disk. Now, in this diagram, we're showing the flows and the policies being deployed into a server and then stored on a public configuration store. This is really just saying public in the sense of there's public definitions for what those artifacts should look like. I don't really mean public here in the concept of a publicly accessible web browser or file system, anything of that nature. This is still very much deployed as software. It's on privately held disks, privately held computers. But the fact that it's got a public definition, is no longer internal or proprietary in any of its ways, makes it much more amenable for use, particularly in container-based architectures where you want to execute an architectural model that's often referred to as unzip and go. In this instance, all you need to do is start up the server process to point at that public configuration store as one of its parameters, and then the server will start and it will read in all of the artifacts that it needs to know about directly from that disk system. So very fast to start up, and not actually requiring you to hook up a tooling or any kind of automated process to deploy artifacts into that running system. You can already have them laid on disk. You can already build them into a Docker image, which is then just simply started as part of running your Docker container. The last thing to note on this chart is in the bottom right corner, where we've also got the integration node that was reintroduced to the architecture in FixPack 1 of version 11 earlier this calendar year. Originally that was provided as a tech preview, and then that status was lifted in 11.0.02 and is now fully fledged part of the product. So it's fully supported to use an integration node and node-owned integration servers with version 11. And for those folks that aren't quite ready to adopt containers yet, you still have that flexibility of getting advantage of all of the new functionality, aside from the fact that we run nicely in containers, by switching to version 11. So if you've not already done so, hopefully after this presentation you might go and check out version 11 and see how that's running. So we're now going to dive down a bit. We're going to have a play around with some of the tools. We're going to have a look at some of the products in action. In order to do that, we're mainly going to be focusing on the toolkit. Typically, what you would also do is run an integration server process. So at the very base of this chart, I'm showing the starting up of integration server. I don't have a separate create and then start step here. I'm just running the integration server command. I'm pointing it at a working directory. It's an area on disk. I'm providing it the port numbers to use for the administration API and then also for HTTP traffic. I've just selected a few very basic parameters on this chart. There's a whole bunch of extra parameters that you can provide via a YAML interface, which we'll talk about in a few charts' time. But in very basic terms, it enables us to run that server. This is showing you that within the toolkit we have a set of tutorials, and those are a very good starting point if you're just coming up to use version 11 for the first time. So we've got the top 7 in the list there, which are providing some new concepts in version 11, some quick and easy to follow steps. They can each be completed in roughly 10 to 15 minutes, and it's a nice way of familiarising yourself with the new product, even if you're an experienced existing user of Integration Bus version 10. And we've already talked about the fact that there is this new REST API. This is showing you an example of a GET verb executed directly against a running server through the root URL fragment of API v2. In this particular case, we're reporting back all of the standard properties of the server. There are some descriptive properties that you can see here. They're the common kind of properties you'd expect to see, so things like the JVM min-max heap size, what the process ID is, whether or not statistics is turned on. Those kind of things are available here. We also have a set of available actions. It's between line numbers 49 and 59 on the chart here. This is showing you things like how to turn on tracing. Typically, these kind of actions that we would execute against a server are non-persistent actions. We are intending to offer patch verbs as part of a more persisted form of our REST API in future FixPack releases. But for the moment, typically you would use these REST API calls in order to influence changes to a running server, which you wouldn't necessarily expect to be persisted when the server restarts. And we've got a set of other parts to the hierarchy here. So if you navigate down beneath the top level of the server, you'll be able to see other children. We have resource managers, we have policies that we've talked about, we have applications, and they would own flows and other kinds of artifacts. So there's a descending hierarchy here, and as you slowly build up your URIs, you'll then be able to run applications that can do all kinds of scraping against those running servers and the running applications to figure out more information about them. So that's a very basic introduction to the REST API. Let's now have some playing around. Let's go into some demonstrations of the product and see things in action. Typically how we'd want to do that is to start from our development toolkit experience. So what I'm showing on the screen here is a relatively clean workspace. I've imported a few artifacts that you can see in the application development view in the top left corner. Those are very similar to the artifacts that you've used in earlier versions. They're imported either through our tutorials that I mentioned, which you can always start by exploring, and then click the import button on those tutorials. If I was to start up one of these tutorials, you'd be provided with an import button down in the bottom right corner here that would take a project interchange file and bring those artifacts in. So all the artifacts that I'm playing around with here are available through those tutorials if you want to repeat any of the steps that I'm showing here. The first thing to note in the bottom left corner is that we now have an updated Integration Explorer view that has inside of it both the concept of showing integration servers, those standalone servers, and also integration nodes as well. So if I was to connect to my local machine here, I happen to have running a local integration server. I can provide the IP address and also the port number for that server, so I can look at more than one at once. I could have several integration servers all running at the same time on one system. I could have them running on multiple systems. So my last one that I'm going to add here is to port 7603. Each one of these different servers is currently running unsecured, but obviously you have the option to provide usernames and passwords and to do authentication against those servers when we make a connection. And in this particular case, I've already pre-deployed some artifacts into those running servers. So that's simply executed via the standard drag and drop of broker archive files that many will be familiar with from earlier versions of the software. And what we also have here is the concept of integration nodes. So I can connect to an integration node. Again, I'm running that on my local system. It's at this stage where I have to try and remember the port number for that one. I think that was, yes, 4417. I have this running test node, and underneath it, again, a couple of node-owned servers there as well. So you can mix and match here between both integration servers that are standalone and also those that are owned by an integration node. So far, so simple. Pretty much straightforward for those existing users of Integration Bus version 10. If we now switch to a web user interface, what you'll notice here is the fact that I'm looking at a web user interface which has actually got available the chance of toggling between a view for nodes, servers, and then ultimately integrations as well. You'll notice in this particular web UI, I'm looking at two different servers. I've got server 1 and server 2 here. They're the same two servers that I just added to my toolkit. In this particular web UI, I'm actually going again to a local host, to a totally independent port, 8302. Now, what I'm actually doing here is serving up this web page from an integration server whose only role in life is to serve up this web UI, which is, if you like, a portal viewing into other integration servers. So actually, ultimately, this is just an Express application that's running here. So we've got some Node.js code, some JavaScript code that we're running as part of our serving up of web pages for administering the product. And we're then passing those all through a single point in order to provide this amalgamated view. So this is kind of handy if you want to see the concepts of multiple servers all at once. I'd already added connection information here for servers 1 and servers 2. I can add a further server here, so I could create a connection to integration server 3. I can provide the address here, so I'm going to go to localhost on port number 7603. And I'm going to click the Save button there, and I've now got the 3-server view here up and running. I can descend into any one of those servers. So by clicking on it, I can then see the content of what has been deployed. So in this case, I have a REST API and a shared library and a separate application deployed into this one. I can go back up the breadcrumb trail in the top left corner of my view, descend into another server and look at its contents as well. And what I can also do is, by using the toggle in the top left corner, switch to a view of integrations, which shows me everything that's now deployed across all of those 3 different servers. This is now the amalgamated view. So if you wanted to see at a glance everything that's running across your network, it's a quick way to do that. You've also got a search box and a filtering capability, so I could look at just applications, for example. I could look at just REST APIs. I could look at an amalgamation of REST APIs and services. You get the idea. And I could also filter things based on their starting or stop state, and that's very straightforward in order to do some very basic filtering of what's available there. So, very quick navigate around, an administration UI that enables you to see what you've deployed, in addition to the development toolkit for generating and deploying those artifacts. So I'll now switch back to our PowerPoint and rejoin the slideshow. So what I just showed you there is the ability to connect across the admin REST API using both of those tooling experiences. When we do that, we're actually connecting across that admin REST API, which can also then be secured. So we have authentication and authorization that can be applied there, and that's done using a command that, again, should be familiar to Integration Bus users. The MQSI web user admin command can now be pointed at a working directory. So the -w parameter here is defining the area on disk where that particular integration server stores all of its necessary requirements, all of its configuration information. The -c parameter here is to create a user. I've given it the name Ben Web User and a password to match. And then if you'd like to, you can also use the -r parameter to map to a particular role. So you can set up that role to define what the user is enabling you to do with the server when you connect to it. So it's saying, if I connect to that web user interface using Ben Web User, I get my password set up correctly, I'm then mapped to the admin role, and that tells me what I'm allowed to do to that server. Now, that definition for what the permissions are for that particular user, that can be set up using a YAML file. It referred to it here as server configuration YAML, server.conf.yaml. And that's used to specify what those privileges are, and a whole plethora of other information in order to configure how that server behaves. What else is new in version 11? Well, we've radically changed our HTTP technology in this version of the product. We've had HTTP listeners with Integration Bus for quite a while. We actually provided that technology courtesy of the open source Apache Tomcat capability, which we've embedded in the product previously. So the diagram shown on the left side of this chart demonstrates the fact that we use that Tomcat capability in order to receive communications over HTTP, over that TCP stack. Now, ultimately, when we've received one of these requests, we then pass it via a work queue, which is just an in-memory queue. So this isn't like a physical queue on disk, a physical MQ queue. This is an in-memory queue which crosses the Java native interface to then pass that information to one or more of our message flow threads. So in the diagram on the left side of this chart, that's showing how that architecture used to hang together. This was great for a lot of reasons, actually. Having two different thread pools, one for the transport and one for the individual message flow threads, is a really nice way of being able to scale the product. So this enables you to independently scale those two different thread pools so that you'd frequently have maybe multiple threads coming in over that socket, all being serviced by the same message flow thread. So that's a really powerful architecture. But if we look on the right-hand side, one of the major disadvantages that it had has now been improved upon. We're no longer crossing the JNI. So the technology that we're now using is a C-based HTTP listener, libvhtp. This is an open source library that we use embedded within the product. And it again enables us to separate the transport from the individual message flow threads, but it doesn't require us to do that hop from Java, from Tomcat across the JNI into the C code. So we still have the concept of a work queue happening here, but we can do this at much greater performance. We haven't yet published public performance numbers for this feature, for these capabilities, but we are quietly confident enough to say in forums like this that we expect it to be a dramatic increase on the HTTP performance that you may have seen previously. It can be anything from single-digit percents up to maybe 30% performance throughput improvement. It really comes down to whether or not the scenarios you're dealing with were heavily transport-based, or if they were more focused on complex logic within a message flow. So if you're doing heavily complex kind of transformation code, you might see percentage-wise smaller improvements there just because less of your total time was spent in the transport. So HTTP listener improvement. What we also have is the ability to run the HTTP listener both embedded within an integration server and also as a node-wide process. So what some users of integration nodes have quite enjoyed in the past is this ability to have a single HTTP listener listening on one port, which then sprays the content to one or more flows, which have all got different registered URL fragments, but all based on the same IP address and the same port number. So for that purpose, we still provide you an integration node-wide listener with version 11 as well, but still baked on top of this new technology, so performance improvements regardless of whether we're talking about servers or node-wide. This chart summarizes the fact that we have this server config YAML file. So I've mentioned it a couple of times. The purpose of this file is to provide a much larger set of parameters that can be used to control the integration server's behavior. So you can see here all of the kind of things we talked about before, the JVM heap sizes, the statistics settings, and multiple other parameters besides. Now that server conf YAML file, that tends to sit inside the main directory for the product. So we've not yet talked about what the file system looks like when you use one of our integration servers. So the standalone integration server has a working directory. We saw a reference to it when we ran the integration server command earlier. And what that enables you to do is to support multiple subdirectories under it, both a run directory, an overrides directory, and a config directory. The run directory is where we store on disk everything that's been deployed. So if you issue a deployment through a broker archive file, or if you do an unzip and go using our new MQSI bar command, you can lay that content down on disk inside the run directory, shown in the middle at the top of this chart. That has all of the applications there that have been placed onto disk. In the config directory, we've got pretty much all of the other configuration information that a server might need. So if you're using our IRB switch component, or if you're familiar with any of the registry settings, or the user IDs and passwords that we might store, all of that kind of information is stored in that directory structure underneath config. And the last one, the overrides directory, that's enabling you to override policy settings which have been deployed through a broker archive file. This is a topic we're just going to come on to discuss in much more detail right now, in fact. So underneath this working directory, we've got in this example a simple run directory, which has got a couple of applications deployed to it. They've each got a message flow, and we've also got shown here a policy project. The policy project holds inside of it a policy. We haven't actually seen what those policies look like, so what better time than to dive into how we might do that inside the toolkit. I could come into my toolkit and I could create a new policy, and that requires me to have a policy project, so I could call this my policy project. And within that policy project, you can define one or more policies. So I'll just create one for the moment. And a policy, I've mentioned, is pretty much similar conceptually to a configurable service, but it is an artifact that is now stored within your workspace, within these project structures, so that you can check it into and out of version control and also deploy it through a broker archive file. So you've got multiple different types of policy. Some of the more common ones might be JDBC providers, for example, where we've then got templates set up for different kinds of database. So very similar concept here to a configurable service. So if I was to switch to Oracle, it's giving me a confirmation message here saying, oh, you're about to make a change that you haven't saved it yet. Are you sure you want to do that? Yes, I'm quite sure. If I change it to be Oracle, you can see that it's changed some of the settings here to refer to the location of an Oracle JDBC driver and what thin client URL to use, that kind of connection format. So we've got the idea here, the concept of a policy that can be created and put inside a policy project. So how does that then translate when we start talking about the deployment of those artifacts? Well, we've got the idea of a message flow, and a message flow might have a node inside of it, such as a file output node in this example, that refers to some properties that are provided as part of a policy. So it might refer to, for example, the connection information for an FTP server, for example. Those settings are stored within the policy, and you can refer to the policy directly from a node's properties. So we're using a new style of syntax here with the curly angle brackets and then the colon character to denote the name of the policy project and the name of the policy that it has inside of it. So for any new message flows that you create, you can refer to policies in this very simple fashion. And of course, you may already have existing message flow collateral which refers to configurable services, so more on that from a migration point of view in a moment. And now let's also imagine that you've deployed one of these message flows, but then you've also got an overrides directory specified with a couple of policy projects, which just so happens one of those has the same name. So we have policy project 1 here, again with a policy A inside of it, inside our overrides directory. That one's going to take precedence over the one deployed into the run directory. So what happens here when you start up a server is we take the run configuration first, we then take the override configuration and overlay that on top, takes precedence over the run configuration, so the administrator is still king in the new universe still, and that's all then held in memory in order to then do the running system, so in order to have the server run its flows. All of that's held in memory as the current configuration. One final thing to note on this chart as well is the fact that we have the concept of a default policy project as well. So if you wanted to, you could refer on one of your message flow nodes just to the name of a policy without the qualifier of the policy project. In fact, if you're migrating a message flow which previously referred to a configurable service, by default we'll take the name of the configurable service and we'll use that as the name of the policy. So our migrate tools basically take all of your existing configurable service content, create the equivalent policies and place them inside a single project as part of your default policy project. So as the location of last resort, if we've not located your policies, we'll go look inside that default policy project to locate them there instead. So that's the concept of how policies work and how overrides work, all pretty straightforward. I mentioned earlier the fact that we have servers that are not only standalone, but can also still be associated with an integration node as well. So the real reason to include this chart in the deck is just to mention the fact that we have that concept still available within the product, and we also have the concept of a node configuration YAML file, which is used for node configuration. What this also means is if you have multiple servers that are owned by a node, you can place some of your configuration in that top-level node conf YAML file, and then you can override your server's behaviors on a server-by-server basis. So in the past, you might typically have done that using a change properties command. You can now do that using the override copy of your server conf YAML in order to apply different settings from one server to another. So the summary of this chart is that we've really got an inheritance model here, that when we create a server for the first time, it inherits the settings that you've got from the node-wide settings, and then enables you to then make things more fine-grained and tweak them on a server-by-server basis if you'd like to do so. What else is there in the product? Well, we've still got accounting and statistics. This is giving you a real-time view of how your flows are performing. We provide those views within the toolkit. So the little graphics that we have in the top left of this corner are taken directly from our web user interface, and they enable you to see things like the flow stats. So the number of input messages that have come through the system, the total elapsed time, the min-max average CPU time, min-max averages for all of these settings are basically there. A whole different array of settings, probably about 20 different statistics in total as part of flow statistics. Flow statistics can be turned on and off via the settings in the YAML file, and from Fixpack 3, as mentioned earlier, we've also provided the command line commands in order to turn on statistics as well. So if you decide to do that after you've already started up your server, you can do that using those commands directly. It's also possible to find out what's happening within a server, not just looking at its behavior statistically, but also by looking at the event messages that it produces. In the past, those would have been provided into the event log, the system event log, so Event Viewer on Windows or syslog if you're talking about Unix platforms. Nowadays, you can also, with ACE version 11, pass that information directly to the console to standard out. So if you're running an integration server in standalone mode, you can pass that using the -- console log setting from the server conf YAML file, and that will enable you to see in real time what those responses are without going digging around within your event viewer. What's also shown here is the fact that you can send events to our public cloud service as well, and view those there. So we've got a Kibana dashboard here running on top of the Elk stack, which is shown as part of the IBM Cloud Log Analysis service, which is available as part of our public cloud platform. So this is enabling you to then see the same kind of events that might come out through event log messages, but also view them here inside that public cloud dashboard. So if you wanted to centralize your dashboard and have lots of events from all through your enterprise sent up to the cloud securely so that you can view them all in one place up there, you can do that as well with part of the product's capabilities. We also mentioned earlier on that you can turn on the statistic snapshots. That little pop out there shows you some of those settings. What this page is looking terribly busy, this chart, apologies for that, but what we're really showing here is that the event log capability, the fact that you can push those messages out to the console, they can be provided in a couple of different formats. So by default, we provide those in a very human readable format, which is shown at the very top of this chart. If you'd like to, you can change that setting rather than it being the default text. You can change that to IBM JSON, and what that will do is switch the output of those log messages into a JSON format that you can see in the main and big picture as part of the center of this chart. And why that might be particularly helpful is if you're wanting to scrape those entries from standard out in order to push them into some other kind of logging service. So if you'd wanted to push them into Splunk, for example, or into an Elk stack, it's another way of doing it. We've actually used this capability as part of our shipment of AppConnect Enterprise images that run on top of IBM Cloud Private, so the ICP platform. Back in late November time, we provided you some pre-built Docker images which include the AppConnect Enterprise software, specifically for deployment on the Cloud Private system. And as part of that, we have a little client that's embedded within those images, which can take these events and then push them into the standard ICP platform views of the events that are coming from all of your different pieces of software. So a real example there of how these JSON formats are helpful. This chart is talking about something which will be particularly of interest to existing users. So another couple of topics left, this one and then finally one very briefly on migration. And it's the concept of a default application. So AppConnect Enterprise version 11 is obviously the latest release of a long-running piece of software. And over time, our relationship with the artifacts that you defined has changed subtly from one release to the next. So this is, if you like, a kind of a historical slant on the concept of what a default application is. And I'll come to that by the end of the chart as it builds up. So in Message Broker version 7, so going back quite some time now, that was, gosh, that must have been, version 8 was 2011, so version 7 must have been around about 2009, ancient history, 9 years ago. And in part of Broker version 7, we had this concept of integration projects, or broker projects as they were previously called, which deployed top-level content. So all the flows and the message models that you can see on this diagram here were essentially shared. They're all pushed into one container, one execution group, as it was called at the time, and you had forced sharing. Everything was able to see all of the other message models, all of the other flows. And then when Message Broker version 8 came along and Integration Bus version 9, we changed that concept to allow you to isolate sets of artifacts from one another. So we had here the concept of an application with a static library inside of it as an inner container, if you like, an inner section, inner scoping within the integration server process. So that was isolation. You could deploy these artifacts separately. You don't influence one set of artifacts by deploying a different set. And then version 10 came along, and obviously give users a good thing. They want both the good thing and the older thing. So then in version 10, we provided another new concept, which was shared libraries. So if you'd like to, you can deploy one set of those artifacts and then share them between multiple applications. So from version 10, we've now got both those concepts wired together, both static libraries and shared libraries, and also still that top-level content from the Message Broker projects as well. All of that available in IB version 10. When we move into AppConnect version 11, we still allow you to deploy all those same kind of artifacts, even going back for the things that are 9 years old back in those version 7 timeframes. But if we come across top-level content, compiled message flows, CMF format flows within your broker archive file, then all of that content is placed into what we now call the default application. So this is everything that was previously grouped together at that top level, but now we've put that inside, if you like, a pseudo application. And that makes our administration much cleaner. It makes all of our interfaces much cleaner. It makes our REST API much cleaner for interacting with that server. That does mean that there are some slight behavioral differences with version 11. If you've chosen not to adopt applications, libraries, static libraries, shared libraries, all of the more recent concepts the products provided, source deploy that came along in version 8 as well. So there's been lots of these different enhancements that some folks may have decided, oh, I'll just put that off for another day and not upgrade and not use those capabilities. So we're starting to get a little bit stricter here, in the sense that if you do have those components, they'll still deploy quite successfully, no problem there. We'll still deploy the top-level content, but we do put everything forcibly inside to that default application now inside version 11. And in order to deploy them successfully, you do need to tell us what name you'd like to use for that default application. So you can specify the fact that there's a default app there, and you can see the example here. That's just done with one of the simple parameters passed to the integration server command, or defined inside your server conf YAML file. So that's the concept of a default application, some deployment behaviors there associated with it as well. One of the things that I'm just going to leave you with here at the end of the presentation is obviously the topic of migration. When starting to think about moving from earlier versions of Integration Bus, what you typically might do is take your artifacts, take a new cut inside your library system inside version control, and then deploy them to your new system. However, there are some set of users out there that don't want to go that approach, and they would rather go much more aggressively using a big bang approach and have everything converted all at the same time and not go through that more kind of staged piecemeal approach to migration. And for those users, they may in the past have used the MQSI migrate components command in order to achieve that. Now in ACE version 11, we've got a slightly different command that we call the MQSI extract components command. Now, this first set of steps is actually the same in both cases. So what you would typically do in this installation is to install ACE version 11. You could do that alongside the same older version, IB version 10 on the same system, or you could put it somewhere entirely different on a different system. And then what you'd run is the MQSI backup broker command on the artifacts on the older version. So on IB version 10, run the MQSI backup broker command. That would create a zip file with all of the content of that broker. And you could then move that zip file around. So if you wanted to, you could copy it from one machine to another and then use the MQSI extract components, or do everything in one place. It's entirely up to you which way around you do it. And the purpose of the MQSI extract components command and the parameters that you provide to it is to create a working directory which has inside of it converted configurable services as policies inside a policy project, and a set of flows deployed as well. So we have here the flows that have been extracted from that backup, placed into the working directory, so that when you start up your integration server, it will then start up those flows. So this is a command that's very similar in concept to the migrate command, in the sense that it's taking that proprietary on-disk storage for all of those artifacts that have previously been deployed without you needing to do a redeployment, but it's extracting them so that it fits in with this new world of unzip and go, placing it inside that working directory in order to start up. And you can do that multiple times. So you can run that command and have multiple different server directories, each with their own both node-owned servers and also standalone servers as well. The other thing that, of course, to say here is that you might well still want to take the old approach. So the vast majority of users moving to ACE version 11 will most likely start off by just taking a branch in version control, checking those files out from that branch, and then opening them up inside the ACE version 11 toolkit and deploying them either using the existing broker archive files or newly compiled broker archive files down to that version 11 runtime. So that's still perfectly legitimate as the most common way that users would then migrate from one version of the product to another. The final step would be to uninstall the previous version. So when you're happy that you've done that migration, you've moved into production with version 11, you've sent IBM a rather nice letter saying, thank you very much, chaps, you've done a good job, we'd like to be a reference customer for you. And then at that stage, you're ready to uninstall the previous product and move forward on that basis. So with that gives us happy hunting on a version 11 AppConnect Enterprise basis. At this stage, I will just say thank you very much for listening to the recording. And if you've got anything that you'd like to follow up with, you can do that either directly via email to me or to our task IDs, which we will also share in the session. So thank you very much.
Okay, so with that, we will go ahead and open it up for Ben to address any Q&A that has come in. Ben,
Thanks, Kelsey.
there?
I am. Can you hear me?
Yes, I can hear you.
Great stuff. So we've had a really healthy chat through the web tool as we've been going along. So I think the majority of questions have been answered there, but I will look out for anything further that's put in there as I'm speaking, and I'll selectively take a few of those for direct comment. Where I'd like to start is obviously we've been hearing a lot about the architectural and the administrative changes that we've made with the product to make it really nice for running in container-based architectures. So hot off the press, I just wanted to mention a couple of other things in that particular area. So we've been building a set of Docker images and Helm charts to help you deploy the software to an IBM Cloud private system for quite a while now, and they've been available just publicly as part of our GitHub organization. But building on top of those capabilities, IBM's recently made another announcement regarding an entirely new release, which is going to be known as the IBM Cloud Integration Platform. And that's going to offer you a single unified platform that allows you to deploy integration capabilities really quickly and simply into that IBM Cloud private environment. So this really helps you with time to value by giving you monitoring, logging, security features all baked into that single environment. And we're going to be talking a lot more about that topic at IBM Think next month. So please feel free to tap us up for that information at that stage. But just to mention, if you've not seen it, that announcement is now out there and public. On the topics that we've talked about as we've gone through the session, an awful lot of interest around how we migrate into version 11 and the various protocols that it supports. So we've been answering topics there around authentication and authorization for the web UI and the like. There are some features which has been noted by some of the questions there that were in version 10 and haven't yet made it into the version 11 product. So you'll notice as it flies through there, one of them was the global cache capability. We're actually working on that right now. I am confident that will be delivered as part of our next fix pack, 11004. It's not quite there yet, and that's just to say we've certainly not forgotten about that use case. That is likely to come in that version. The other thing that users may come across in an area of V10 migration regards the record and replay functionality that I'd make very similar comments on. That's something that we're working on right now, and we're expecting strongly to be in that Fix Pack 4 version of the product that's due for release. What else have we got that's come through here? There are questions around our cloud capability and how the integration nodes and servers are managed. So what hopefully came across from some of the demonstrations there is that we now have the chance to have a mixed estate of both standalone servers and integration nodes all mapped together in one place. So you can view those separately through the toolkit or, of course, administratively through the web UI capabilities that we've got there too. So there were a few questions regarding how you might connect and disconnect from integration nodes inside the toolkit. You might see some subtle differences between the menu options there. Whenever we connect to those runtimes, we offer it through our REST API these days. So rather than displaying by default all the locally defined integration nodes, now from the toolkit you specifically set up connections to those that you're interested in. So there may be a little bit of confusion just tied up there with the difference in options that you may have seen in the V10 UI. Another question that came through was regarding event processing nodes. So we do have all of the event architecture nodes available in version 11. So that includes the timers, the sequence, the resequence, the aggregation nodes are there too. All of those nodes require a local queue manager. What we've added in version 11 is group nodes, which are a stateless form of that, or rather an in-memory state form of the aggregation nodes. And those that still require the queue manager, although they're supported in ACE version 11 software, they're not yet available in our cloud offering. So you can use group nodes in the cloud offering for aggregation use cases, but timer, sequence, and resequence are still to be added for the cloud, hopefully later this calendar year on that one. Other things that I've seen fly through. Let me go right to the top of the list rather than just regurgitate some of the written answers. Let me see what's come in more recently. So somebody's asked about the healthcare connectivity pack. Right now the healthcare pack is only supported on a version 10 runtime basis, but again that is something that we're planning on ticking off our list sometime very soon. We're going to be starting work on that very shortly. Can an integration node manage integration servers across multiple hosts, VMs, and Docker images? Yes, absolutely. So the integration servers can be defined in all of those different places. What we saw in terms of the combined web UI, that was actually an integration server that hosted the web UI pages, which are ultimately formed courtesy of us making separate connections to all of those servers and hosts. So this isn't so much an integration node managing those separate servers. It's really, if you like, a single UI which happens to be hosted within an integration server, showing you those views across all of those different component parts. Now, ultimately, that's just a REST API connection that we're using to those separate servers. And it's the same thing that we build our dashboard on. When you look at the ACE deliverable as part of our IBM Cloud Private solution, we have a very similar dashboard offered there that enables you to connect to one or more replica sets with all of those replicas defined. And you can do that with the UI that's offered as part of that Cloud Private system. And that's exactly the same kind of technology that we're using there to enable that multiple management to occur. So we're providing that there both in software terms and also in the Cloud Private software terms as well. I'm going to flick through to see what else is here. Somebody's asked around the topic of the AppConnect Enterprise Designer capability. That capability is only currently available in the IBM public cloud, in the managed cloud. But it's an area of investigation that we're looking at right now, where, again, later this year, we're expecting to start taking artifacts that have been created in Designer for deployment to software. So if you're particularly interested in that area, then please do join our beta programs, our closed beta programs, where we can talk more openly about those kind of future plans that we have. So correct, at the moment Designer is only used as part of the public cloud offering, but that may not be the case when we move forward into the future later this year. Other questions? We see here somebody's asked about the IDE and runtime installation and the scope. Will it be unzipped and used directly for all platforms? So the idea here is that the installer is a combined installer for both the runtime and the IDE altogether. It should be said that earlier versions of Integration Bus, in fact prior to version 10, allowed you to separately install the toolkit and the runtime. The reason why we combined those as a single combined packaging exercise in version 10 back in 2015 was that we really thought, well, anybody who uses the toolkit would typically want to have a very lightweight local installation that they could test their flows against quickly and easily. We traditionally had some users that were very confused when they had to install the runtime separately and set up those connections manually, which is why we took that change in direction. So there is still a small use case, I would acknowledge, for those users that want to do automated installs of the toolkit across many hundreds or thousands of machines, who might therefore appreciate a smaller installation size image in order to help with that exercise. I think that's pretty much the only remaining use case for a separately installed tooling. And it's not something that we're working on right now, but if we were to get enough of a landswell of support on that area, then we'd certainly look at revisiting that particular request for enhancement. But it's not something that we're planning on doing right now. Someone else has asked very recently about a date here for ACE on AIX. This is something that we were working on throughout the end of last quarter, so we have actually made very good progress on this one, but it's not quite ready for delivery yet. So we're expecting to have very good news on that later this quarter. But we have no announcement that we can make formally at this stage regarding a specific date. So we'll see how that one ends up playing out, but I would just like you to continue watching that space. That obviously get questions come in from Martin, so we're well aware of that one. Obviously, you're on our beta program, so if you want to drop me a private note on that, I can expand a little bit further. But yeah, the plan is still for us very much to support the AIX platform. We're just not quite at that stage yet at this current point in time. Other questions? Are there built-in nodes to connect to AWS S3? There is not a built-in integration node capability there with S3. We have actually got some example code that we provide on our GitHub repository for that one, but that's not been rolled into the core part of the product. There hasn't yet been enough widespread interest in that one, so we've not taken things any more formally than that example that we've provided on GitHub. So I guess a good starting point would be to go and take a look at that and let us know if that's the kind of thing that you're after, and if so, then we'd track that through a request for enhancement. How long have we got? I reckon another 5 minutes at the top of the hour, so please do keep typing if there's something further that you're interested in. Let me see what else I have in here. There's a question about Websphere ESB migration and conversion. So we're still providing a tool as part of our toolkit to help with those conversions, but that's not something that we're enhancing any further in version 11. That technology, we've got the majority of our users moved away from Websphere ESB onto IRB version 10 prior to ACE's release. So we're not going to be putting anything further into that particular functional area, at least certainly not expecting to at the moment. So there is that conversion tool available still as part of our toolkit, but nothing further that we're planning on functionally adding to that tool as things currently stand. Somebody else has asked about the process of moving to ACE from an older version of the product. So what hopefully came across in the webcast, the recording that we gave today, is that you can absolutely take artifacts from version control, bring them into the more recent version of the toolkit, into ACE v11 toolkit, and then deploy them, either by reusing bar files or by compiling a new version of those bar files. And that's probably the most commonly used method of taking your artifacts to the new version. For those users that don't want to have such a process, that wants to do everything straight away, all in one big jump, then the extract components command that we talked about in the webcast, that's the way to do that one. And that provides you the chance to do it without necessarily getting involved in the tooling story. I would always advise users to go the tooling route, the piecemeal route, just simply because it gives you more control to do things a little piece at a time rather than all at once. So that's the more common method of movement migration from earlier versions. There are others, but I don't think I'm going to be able to do justice in the time I've got here. So somebody's asked about the different kinds of product that we have, both API Connect and App Connect, and what the differences therein are between those products. So very briefly, API Connect is focused much more on the management of APIs and controlling the SLAs for invoking those APIs, whereas the App Connect product is much more involved with creating REST API definitions that are an integration facade onto other systems of record, and is really much more about the integration aspects of APIs. We acknowledge that does mean that we've got different products within the IBM portfolio where you end up looking at open API specification-based artifacts. And that's something that we are absolutely planning on doing something around when we talk about that IBM Cloud Integration Platform release that's recently just been announced. So we'll be going after those combined kind of use cases where we can showcase the power of both of those products under one banner, under one set of UIs as we move forward with that offering. Somebody else has mentioned that Webster USB is still used by BPM Advanced product. That's absolutely correct, Michael. So that's correct. The technology is still there. If you want to continue using Webster USB, you can do so under the BPM Advanced banner as well. Somebody else has asked about switch integration support. So for callable flows, switch integrations are still available. So we still have the switch server command. We still have that capability in the more recent version, version 11. That is currently offered on Linux and Windows X series. Specifically as part of that question you've asked there about AIX support. We are intending on enhancing AIX to also include that capability when we offer the AIX platform. So some good news on that one coming your way soon, if that was the intent of the question there. With that, it's a really whistle-stop tour, but I think that I'm just about coming up to the top of the hour here. So by all means, if there are things that I've not had the chance to get to, I think there may be a couple lurking through this list that I've not read out or had a chance to respond to. Apologies for that. It's been a real whirlwind of people on this Q&A chat here, so I'm sure there will be something that I've missed, but please do reach out if I've missed you and we'll pick up the conversation therein. And with that, I'll hand over to Kelsey in terms of a final wrap-up slide that I think we might want to just say a couple of words about.
Yeah, thanks, Ben. Just a couple things on the slide here. Thank you for attending. Ben's contact information, a link to the middleware user community to continue asking any questions in our discussion forum. And we also have a couple other links to our next webcast coming up in February, and then also a link to register for Sync, which is coming up in February as well. So With that, we'll go ahead and end today's session. We will have the replay and slides available tomorrow, so stay tuned for an email that you'll receive in your inbox with a link to download everything. And that really concludes today's event. Thanks, Ben, and thanks everyone for attending, and have a great rest of your day.